let's go ahead and learn some key tools that will help us to count better and more elegantly. Remember, maths is not just about calculations, it's also about putting difficult concepts in an elegant manner that is easy to understand, as long as you, of course, know what or how to read it. Now, the factorial is the first thing that we are going to discuss. It's a number that has an exclamation mark in this format. It's something we've never seen in other grades. So the factorial works like this. Let's say that we have 3 factorial. The calculation means that you must take 3, multiply it by 2, and then multiply it by 1. So you go all the way from the number down to 1. And that would give you that the total answer is 6. Another one that we can look at, for example, is 4 factorial. That would be 4 times 3 times 2 times 1. So that would give us a total of 24. So that's what we talk about when we say factorial. Of course, it's things that we've seen when we did the manual counting principle of spaces, but it's something that we can use and that the memos use for grade 12 especially, and higher levels, of course, to do the counting in and represent it in a more elegant way. So the formal definition is that if you have a number factorial, you are going to take that number, multiply it by the number that comes before it, multiply it by the number that comes before that, and then keep going like this until you get to 1. So that is just the idea of it. Now let's talk about when can you use the factorial and when can you not. So the factorial works in cases where you find yourself you are dealing with a word or numbers that are unique, different from each other. They have to be different from each other for the first case, such that you are putting them in the same number of spaces. So for example, for arrangement issues. So if you have arrangement of, so that would be arrangement of n items. It can be people, it can be letters and all of that. Items that are unique. So if you are doing this where you are identifying, so an example of this, let's say we give you the word Chappie. So it has 1, 2, 3, 4, 5, 6, 7 letters, and then you are asked how many arrangements can be made using the word Chappie that are unique. It would be an issue of, because I have 1, 2, 3, 4, 5, 6, 7, my answer would be 3 factorial arrangements. So we are able to quickly do this, or you can go back and do what I showed you in the previous video about spaces, but you will see that this becomes the answer. So that is when we can directly use the factorial as is without any manipulations. Same number of letters or numbers, all of them are different and they need to be just rearranged uniquely. There's a factorial at work. Let's look at the special conditions where we need to add something extra. So we will look at where there's repeated alphabets, we'll look at where there's grouping. So now we are going to look at what happens if there are repeated letters in the word given, or the letters that are given, there are some that have been repeated. Well, how do we deal with that? Because it's going to change the number of words or rearrangements that can be created that are unique. For example, if we are given POP, pop, this POP and that POP are going to give us the same word. So now I've just labeled the P's 1 and 2 just to show you that if this P is this side and this one is that side, it's the same word, so it doesn't count. So also we can have PPO and then we can have PPO. So that would be for 1, 2, that would be for 2, 1. Same problem, it's the same word. But then the idea is you can find all of them, and then you are going to see that what happens is that 2 of each type becomes the same. So the other one that we haven't done is OPP as well as OPP. So we have the same as we had before, that because it's 3 words, there is a 3 factorial involved, but because there are 2 alphabets that have been repeated, we need to divide by the factorial of the repeated letters. So this is how we are going to do it. You will see that this answer gives us, instead of 6, we get 3, because here we will have 3, 2, 1, 3, 2, 1, like that. And then here we have 2 times 1. These cancel out, 3 is left. So we have 3 as the answer for that. So please do understand that when there are repeated letters, you are going to do a factorial and then divide by the factorial of the number of repeated letters. Let's do some with multiple repeated letters. Okay, so here's the situation. We want to deal with how many unique arrangements can be done using the letters of the word church. So when we look at it, there are 1, 2, 3, 4, 5, 6 letters in total, but 2 C's are seen, 2 H's are seen, which means whenever I swap them in their exact places, they will then give another word that is exactly the same. So what do we then do? We get the solution as, first you take the factorial of the total, which is 6 factorial if there were no repeated letters. But because of the repeated letters, you then divide by 2 factorial for the C's, and then you multiply by another division of a factorial for the H's. So we divide by each repeated letter's factorial. However, please, you multiply them in between each other. So this would give us the total for what we are looking for. So that's what we are going to talk about, that if there are repeated letters, please divide by the factorials of the repeated letters, because the idea is as follows. The words come in twos. If there's 2 repeated letters, they come in twos. So we would need to then divide by 2 to separate them and get the unique ones, as we saw for pop. Also, same thing for the H's. So if there were 3 repeated, the letters were repeated 3 times, we would be dividing by 3 factorial, because we know that 3 objects can be rearranged amongst each other 3 factorial times, which is 6 times. So that's the idea of it, please. Divide by the letters of the repeated letters. So that's number 1 and the key ones that they ask for the examinations. Let's look at number 2, where there's grouping of letters. So here's an example for grouping. So here they are asking us how many rearrangements are unique for the word dolphin. So we're using the letters dolphin and have the letters H and P next to each other. So this one I'm going to explain it using the lines first, so that we can clearly grasp what is happening, and hopefully it makes life easier that way. So the word dolphin has 1, 2, 3, 4, 5, 6, 7 alphabets. So we are going to take the 6 spaces or 7 spaces there. And then what you then do, you take the group in a block like this. That this one we are just meaning that out of the 7 spaces, there's 2 spaces that continuously move together so that they are next to each other. So it wouldn't have mattered which letters they are talking about. It's just a matter of there's 2 of them. So the 2 are next to each other. So what do you then do? You recalculate the factorial where they take up 1 space. So that would be 1, 2, 3, 4, 5, 6. So you write 6 factorial. So that is a matter of, do you start with them? Are they second? Are they third? Are they fourth? Are they sixth? Are they at the end? Or whatever space you put them in, they're moving together. But now there's an issue of, for them to be together, it can be an issue of H is first, so we can have HP, but we can also have PH. So that tells you that there's 2 factorial ways of changing them around. So then you multiply by the factorial of the group. So the way I put it is that this is the main factorial, and then this is your group's factorial. So that if there's others that are grouped, you can just multiply by their factorial. So you times by the factorial of the group. So that would then give you what we are requiring for these particular cases.